Today's experiment is about copper cycle. The experiment number 5. Let me make it. Experiment 5, and about copper cycle. We start with element copper, very golden, brownish golden color, element copper. And then we have to recover it back. We start from here and go through all the stuff here back in to whatever we have started with. Correct? We start with a certain amount, say 0.4 grams, whatever. We start with a certain amount. And after all these cycles here, we have to determine how much we have recovered. So the amount of how much we have recovered, okay, divided what's the original one you started with, and multiply by 100%. So that will give you how good your experiment is. Higher recovery, say 70 and above percentage, that's good. If you got lower percentage, you have lost some of the copper somewhere in the process. Filtration, chemical reaction, dissolving, all this stuff is very important. And that's all this experiment is all about. We'll make a lot of observation, a lot of manipulation here, but the main thing is we are looking at percentage recovery. So that's what all this experiment is all about. So this is, I'm taking this one out. So let's start with the first step. So the first step in the cycle is, we'll start with the copper. This is step 1. You start with the pure copper. Okay, and you let the copper react with nitric acid. I'm not balancing those equations. You can balance them later on. I mean, I'm just giving you the whole picture. What's the first process is all about. The second process is all about. I'm not balancing in between those chemical equations. That's part of yours task. You have to balance them when you write the lab report. Correct? And if you have stuck with this balancing chemical equations, come and see me, correct? So, what will happen here, this is a very strong oxidizing agent, correct? So, we'll oxidize copper to copper 2. Copper is 0 here. We just covered this one here today in the lecture, if you recall. And then the copper will go to copper nitrate. This is 2 plus. So copper is being oxidized, and then in the process you will get a brown gas, nitrogen dioxide, and H2O. I'm not, as I said, I'm not balancing now. So just going, this is the first step. The first step, we are dissolving copper, correct? And in nitric acid. This has to be done where? In the hood. Why in the hood? This is a very highly toxic gas, correct? And when I was in Colorado, this gas, they call Denver, is the brown city. The brown city means it has in the morning a lot of accumulation of nitrogen dioxide from the exhaust, from the 18-wheelers, from power plants. This is cause a lot of lung cancer among the infants in Denver city. So Denver city is 1 mile high, the highest, I think, in the nation, and they have problem with this because of the height. They have nitrogen dioxide problem, which had caused through the years lung cancer in the infants. So kids they have a lot of problems with this. So therefore, don't inhale this gas here. So you do this one in the hood when you add, and close the hood. Close the whole window of the hood. I don't want you to inhale any of this This is carcinogenic, so it can cause a lot of problems in your lungs. So, we are interested now in the copper. Copper now is oxidized from 0 to +2. Correct? Now, copper is now in the solution. No more solid. Now, inside the solution. That's the first step. So, this is nitric acid. That's the first step. Number 1. Number 2, we will neutralize. So, first of all, you will add enough. If you see that copper base is still there, add more nitric acid. That's a concentrated acid. And they said in the procedure, your instructor will do it. I can do it for you if you feel it's concentrated, correct? It's about 30%. About 30% the concentrated, or 36%. So, we move this one here. If there are some pieces inside the beaker, just add more nitric acid, so and stir a little bit, if that's the case. But I think nitric acid will take care of this. It's very aggressive. We'll dissolve this one here. The next step, can I take the first step out? Everybody has it? I will be recorded anyway, so it will be recorded. So next step, we have now copper as a copper 2, correct? We oxidize copper to copper 2. So from copper to copper 2. The next step, we have to take this nitric acid. This one here, the pH is what? Acidic. You don't have to measure the pH, but you know that you added acid, so you don't have to measure the pH, okay? But here, when you add the sodium, the next step, hydroxide, that's a base. So therefore, you have to make sure that all the copper is copper 2 transferred as copper hydroxide. This is step 2. Step 2 is you are producing, step 1 you are producing this. This is step 1. This is step 2. So, can I take this one out? Everybody has it? Everybody has it? Okay, let's take step 2. So, this is step 2 here. And I can write it here. We have space. Step 2. We have copper now, not copper 0 as element. Correct, solid. We have copper 2 in copper nitrate. In this copper nitrate, I have copper 2. I will add to it sodium hydroxide. Sodium hydroxide, the sodium is spectator ions. We are not interested in it. What is the reaction is between copper 2 and hydroxide. I get copper hydroxide, which is very looks like very gelatinous, solid. And we have this one here. We transfer this one here. Still copper 2 plus. We did not change. Just transfer this one here. Copper still what in step 2 is copper 2 plus. Everybody is following? So this one here we have to test the pH. You have to neutralize all nitric acid. You have it. You have to make sure that the solution is basic. The solution is basic. Add more just to make sure that you are recovering all the copper 2 from the nitric acid, copper nitrate, converted into copper hydroxide. Okay, guys, that's the second step. Then we'll start copper hydroxide here. Step number 3. This is step number 3. Step number 3. So we'll take copper hydroxide and heat it. Now, when you heat this one here, you heat it where? On the hot plate. On the hot plate. We'll see if the hot plate is doing it, or otherwise we can use open flame. But I don't like open flame because we will see. If we need the open flame, we'll use it because the next step, step 4, you will add an acid to this copper oxide. That's a black precipitate. This is a black solid, correct? So, but still copper still as copper 2 plus. Sorry. Copper 2 still in the cycle, still copper 2. So, we did not change anything in the oxidation number of copper in step number 3. Step number what? 3. So, still copper 2 plus. Okay, guys? So when you heat it, you get what? Copper hydroxide will give you copper oxide, which is black precipitate, PBT, black precipitate plus H2O. Okay, guys? Everybody's following? Step 4, which is coming here. Step 4, this is step 4 here. Correct? Why step 4? Then you take this copper oxide, the black precipitate, you'll add to it sulfuric acid. Sulfuric acid. Now here you have to be careful because you are producing copper. You are producing this here copper, and you are producing hydrogen gas. Therefore, you have to be careful. No open flame near hydrogen. Otherwise, the whole hood will explode. Correct? So when you have this copper oxide here with sulfuric acid, you produce copper sulfate, a blue solution. Let me write it here. A blue solution. And you are producing hydrogen. That's my concern here. So no open flame. When you react this oxide, the black precipitate, you will add enough sulfuric acid until all black solid of copper 2 oxide has to be converted totally to blue solution. Everybody's following? That's step 4. Then step 5, you will add magnesium. That's a single replacement. You will add magnesium to this blue solution, okay? And you will see that magnesium will reduce copper. Then you have this copper sulfate, that's plus 2. Then copper sulfate plus magnesium will give you copper, will be orphan by itself. That's what we need. And magnesium sulfate. So you will see a blue solution of magnesium copper sulfate, but the copper will be by itself. Here when we have to introduce the filtration. So we'll do filtration. We don't have the vacuum. Vacuum's not working. So we'll do this one here with the gravity filtration. So we'll filter the solution, the blue solution out, keeping the copper by itself. Now, you have in this process, you have to have pre-weighed filter paper. The last step, step 5 here. This is step 5. So step 1, but now we are coming from the other side, that will be step 5. This reaction here. This reaction here is step 5. So in the step 5 here, we have to pre-weigh filter paper. Put the filter paper in a funnel, and then there is a beaker or Erlenmeyer, and put the funnel. Let you decant the whole solution out, so the solution will remain out, and the copper particles, correct, will be what will be precipitating or will be then stuck inside the filter paper. But you know the weight of what of the filter paper. You will take this one here with the watch glass to the oven there. I will turn it on. There is an oven in the back. I will turn it on for you. After turning it on, I will keep it just to mild temperature, because if we put higher temperature in the oven, what will happen is you will burn the filter paper. So that your mass of the filter paper, filter paper will be charred or barbecued. So if you barbecue that filter paper, then the mass of the filter paper is not correct. Everyone's following? So we have to have a mild, maybe about 80 degrees, 90 degrees, something close to just to evaporate the H2O coming out. The H2O, so about 90, 100, yeah, so 100 degrees. But we will not put a higher temperature because we are afraid that the filter paper will be really barbecued, and that will have a big error inside the mass of the whole thing, because you weigh the whole thing and then you keep it cooling down the filter paper with the copper inside. You go and weigh it, and then that will be the difference of the filter paper empty with the filter paper now filled, will give you the amount of the recovered copper. But you know what you started with. So those are 5 steps. Everybody's following me here? Everybody's following? Everybody's following? So let me just go and look at the procedure here. So we started with copper, put the nitric acid to dissolve the copper, then put the sodium hydroxide to neutralize this copper from the nitric acid. Then you get copper hydroxide. You heat it, you get the hydroxide goes to the oxide of copper, from hydroxide of copper to the oxide of the copper. You dissolve this copper oxide with sulfuric acid. You get the copper. You then single replacement reaction with magnesium. Magnesium is replacing copper out of its sulfate. You get your copper solid back after the filtration. So the experiment is straightforward. There's no problem with that. So let me just look at now. Hold on here. Let's look at the. Let me see if experiment 5. Yeah, if I look at this, so you can read all of this here, and the main thing is the procedure. This is the main thing what we are looking at today. You see how your work is really good or not good. This is the whole thing. The mass of the copper you're recovering divided by the mass of copper you started with, multiplied by 100. So if your recovery is good, say 70% and above, that's your work is good. If this is about 20-30%, then you have lost some of the copper during filtration, during dissolving with acid or base. So you did not really precipitate the whole thing. So now let's go look at the procedure here, guys. Procedure is straightforward. So step 1, you will weigh just quick. So I don't want to. You weigh about, as I told you, 0.4 grams of copper, correct, pieces, and you put them in a beaker, 250 milli beaker here, and you put first 5 mL of concentrated nitric acid, and you record your observation, correct? Leave the beaker in the hood because NO2, close the window because nitrogen dioxide is highly carcinogenic, can affect the cancer in the lungs. So then if you feel, you have to observe that all the copper pieces are dissolved. If it's not, add more nitric acid, so concentrated. Then you will add 100 mL H2O. Now this H2O has nothing to do with the reaction, but just diluting the whole solution. So step 2, you take your sodium hydroxide here, sodium hydroxide, and then you add 20 mL of it to get your copper hydroxide. Step 3, let's look at the step 3 here. Step 3, after you having your gelatinous copper hydroxide, you'll start heat this beaker, correct, with the hot plate. We will not use open flame, because open flame, if you forget the flame open and then you go for the next step with sulfuric acid, you get hydrogen, you get explosion. So therefore, we'll be using hot plate to heat the solution. Copper hydroxide will transfer to copper oxide. So the copper hydroxide solution is blue. You should see some in the bottom of the blue, some black precipitate of copper 2 oxide, correct? You cool down, and you can see here, as they say, you see the black precipitate will settle down at the beaker. So here it is. That's what you can see here. That's what you see here. Then you see the black precipitate is here, the bottom here. That's the black precipitate here, and that's the blue solution here you have. Correct, guys? That's the blue solution. That's the copper oxide. Then you'll add to it sulfuric acid, correct? Sulfuric acid, when you add it, you will get copper sulfate, a blue solution, plus hydrogen. Now we have to watch for this. This is a major problem. It will cause us if we have an open flame. We'll never have open flame. We'll use hot plate, correct? So that's step 4. And the last step here is, you get your you get magnesium, stir it with the whole thing here. You get the magnesium. Magnesium will kick out your copper sulfate. Will take copper here. So step 5 here. Let me just write it here. So you have copper sulfate. Remember, plus hydrogen from sulfuric acid. We are interested in this. When you add to it magnesium, so magnesium will kick out copper out of copper sulfate, will take over the sulfate, keeping the copper orphan here by itself. The single replacement reaction. So, and then you will do the last step is you do this vacuum, what they call it, vacuum filtration. We don't have a vacuum filtration. You will do what the vacuum's not working. We will do the what they call it. We will do the filtration. Everybody knows how to do filtration, gravity filtration. Let me, somebody will give me a filter paper from the back. I'll show you how to do it. A filter paper in the back. If you can give me filter paper, I'll show you. So, yeah, in the back side where the chemicals are. There should be a filter paper there, just to show you how to do it. So, yeah, in the back. Somebody has it? Yeah, show me. Thank you very much. Thank you very much. Thank you very, very much. So, guys, this is here, filter here. Everybody's following? I'm just putting here this one here so you can follow me here. This is a filter paper. I'll put this on 50%. 50%. Correct? I flip it 50%. And then another 50%. I have it, this one here. Okay, guys? Then the ratio is 3:1. So I keep one, this is like here. Now I have what? I have a cone. Let's see here. So again, let me repeat myself. It is 50%. Okay, guys, 50%. Another 50%. Now I have almost a cone. Open 3:1 ratio. Take 3 sides to one side. Here I have a funnel. Correct? This filter paper has to be pre-weighed. You have to know the mass of it to begin with. Correct, guys? Otherwise, your calculation will be wrong. You have to know how much is it. And will not overheat it, because if it's barbecued, then the whole experiment is gone. It's no good. Your data is not good. Okay, guys? I think that's all. And let's see how much recovery you have. I have in the past, through the years, a lot of students get 80%, 70%, 80%, some of them even 90%. So it depends. If you are doing very careful, your procedure very carefully, you can get good data. But if you rush, you will not get good data. Okay, guys? I'll stop recording. Let's start doing